Part 2 starts with what I consider an absolutely fabulous question. It's always interesting to see who can kind of piece this together based on what we've discussed so far. So Evan graphed the point 5,7, so we'll say this is 5,7. And wants to reflect it over the line, y equals negative 2/5 x plus 6. He predicts the reflection point will be 2, 2. Without graphing, so you don't get the graph, this is all you get. Can you confirm or show that he can't be correct? So is he right or wrong, and how do you know? So I would love it if you would pause this video and think about it for a second and see if you can figure it out for yourself. So here's the thing. We know that if it's a perpendicular slope, it needs to be a negative reciprocal. So we have the slope of negative 2/5. The reciprocal to that would have to be positive 5/2. So if you think about it, what we're saying is 0.22 would have to go up 5 from 2 to 7, which it did, and it would have to go over 2. So 4,7 would actually be the perpendicular point, not 5,7 of 2, 2. So if the perpendicular point of 2, 2 is 4,7, well then for sure the perpendicular point of 5,7 couldn't be 2, 2, because what you would have done is you would have gone up 5 down to 2 and then over 2 to 3. So 3, 2 was actually the point that Evan should have been looking for. And I hope that that makes sense, because 3, 2 up 5 over 2 gets you to 5. And that's what we need. We need to have a slope of up 5 over 2, because that's the negative reciprocal of negative 2/5. So if you didn't follow that, you probably need to watch some of the other videos, or maybe watch it again, because I don't explain things terribly well. All right, so let's go ahead and continue with 314 part 2. So 314 part 2. All right, so translations, and we know a translation is just a slide. So the question is, did this slide in this direction from left to right, or did it slide from right to left? So again, hopefully you have an answer to that, but it slid from left to right. I know that because the prime signals, right? The primes mean it's an image. So this was the original, this is the image. So it had to have gone in this direction. So it went that way. All right, so anyway, let's go ahead and take a look here. Definition of translation. The formal name for a slide is a translation. So what exactly is a translation? Remember, the translation and transformation are different words. Triangle A prime, B prime, C prime at right is the image of ABC. So like we said, it started here and moved in this direction. Describe the translation. How many units to the right and how many units down? I kind of like to go with slope. So it went, I like to go up and down first. It went down 1, 2, 3, right? Down 3, and it went over 1, 2, 3, 4, 5, 6, 7. So it went down 3 and right 7. And this should be the case for all the points. This should go down 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. This should go down 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So you can see it better be the same for all of them, otherwise we got a problem, because we will not have a rigid transformation. So that's the transformation. On graph paper, plot points E, F, G with these coordinates. And we are going to, it says, what are the coordinates of E prime, F prime, G prime if it was translated in the same way? So if we went down 3 and right 7. So obviously I'm going to need to write this down and go to a coordinate plane and do it. It says, for the translated image in part B, draw line segments to connect the vertexes of each. What do you notice about the line segments? And then using trace paper to explain how you know these translations do not change any angles or lengths. So again, I'm going to jot this down and go and do that in a coordinate plane. What it's made to do is plot these points, and then, you know, go ahead and translate these things down 3 and over 7. So down 3, 1, 2, 3, over 7, 1, 2, 3, 4, 5, 6, 7. So this will be my E prime. Down 3, 1, 2, 3, over 7. That will be my G prime. And down 3 and over 7. And that will be my F prime. And then it asks us to kind of get the ordered pairs. So it's going to be 8, 4 here. Here it's going to be 11, negative 1. And here it's going to be 9, negative 3. Hopefully someone will answer that while I go ahead and connect these points. Okay, next it said to go ahead and draw parallel lines connecting. I guess draw lines connecting the vertices and say what kind of points they are. And obviously these appear to be parallel lines. So I guess I want to talk about a couple things. First of all, do you notice that from F to F prime, it went down 3, right? Down 3 from 7 to 4. Remember the X, Y? In ordered pairs, this is the up, down, and this is the left, right. So this number went down 3 while this number went up 7. This number went down 3 while this number went up 7. The Y went down 3 while the X went up 7. So I probably should have said that. Next thing, they asked me to draw these lines and compare. Well, the slope is -3/7, -3/7, -3/7. So yeah, I mean, all of these have the same slope. So these should definitely all be parallel lines. So hopefully we're okay with that. And how do I know the shape is rigid? And it said to take tracing paper. Obviously I can't take tracing paper, but if I did and slid it over, it would look the exact same. But how about this? From this point to this point, I went up 2 and over 2. So from this point, I went up 2 and over 2. And then from this point to this point, I went up 1, 2, 3, 4, 5, 6, 7, and over 1. So up 1, 2, 3, 4, 5, 6, 7, and over 1. So you can see, I mean, if the direction from here to here is the same as the direction from here to here, and the direction from here to here is the same as direction from here to here, I must have a rigid shape. And I guess we can finish it off by going from these ones, right? So I go left 1, 2, 3, and up 1, 2, 3, 4, 5. So I'll go left 1, 2, 3, and up 1, 2, 3, 4, 5. So I do have those rigid transformations. I'll go ahead and pause and keep going. And then jump back over. So connections to algebra. Read the math notes in this lesson, which I think are just about transformations. And, you know, we already talked about rotations, reflections, and translations quite a bit. So that's what the math notes are. So it says plot triangle ABC on graph paper using these points. Apply the function -x is -y. So x and y switch to -x, -y. We're going to find those coordinates. We're going to graph it. And then we're going to see what transformation that was. And then we'll go back and we'll do x minus 6 and y minus 3. And we'll look again what transformation that was. Then we'll get a brand new set of axes and we'll do a quadrilateral. And we'll go x goes to -x and y goes to y. And then we'll see what shape that looks like. So a lot going on here. Again, I'm going to pause it and set that up. This up. So I have this original triangle at ABC. Actually, I should have made these primes. So what they're saying is make the x into a -x and the y into a -y. So A wouldn't be 3, 3. A prime would be -3, -3. B prime wouldn't be 1, 1. It would be -1, -1. And C prime wouldn't be 6, 1. It would be -6, -1. So let's go plot that. -3, -3, -1, -1. And -6, -1. You can see I'm right in my own way, which is unfortunate, but I think you can kind of do okay with that and see what's going on here. Well, again, this is my A prime, this is my B prime, and this is my C prime. It sure looks like I rotated 180 degrees. It doesn't matter which direction, but it looks like this is a 180 degree rotation, right? So that was the first one. Now, when we go to when we go to A double prime, B double prime, and C double prime, they ask us to make a different change. So I'll go ahead and set that one up. Double prime, they asked us to go x minus 6 and y minus 3. So 3 minus 6, like I'm just going to plug this x in. 3 minus 6 is -3, and 3 minus 3 is 0. For point B, I'm going to go 1 minus 6 is -5, and 1 minus 3 is -2, and then 6 minus 6 is 0, and 1 minus 3 is -2, and I'll plot these points. So -3 is 0, -5, -2, and 0, -2. So you can see this is my A double prime, my B double prime, and my C double prime. And if I connect those, it looks like this was a translation, right? So the first one was 180 degree rotation, but this one looks like it is a move about origin. Actually, I should be very specific about that. I need to tell me where I'm rotating or reflecting from. Anyway, this one I went down 1, 2, 3 and left 1, 2, 3, 4, 5, 6. So this would be a translation: down 3 and left 6. And again, that's kind of what I'm getting there. I will pause again and set up our quadrilateral. And we have points W, X, Y, Z with these coordinates. And what it's saying is your X is going to go negative, but your Y is going to stay the same. So for W prime, my X will go negative and my Y will stay the same. Actually, maybe I should be using a different color. So my X will go negative and my Y will stay the same for all 4 of these points. And then I'll just go ahead and plot these points and see what we get here. So negative 3, 7. This will be my W prime. Negative 3, 4. This will be my X prime. Negative 9, 1 will be my Y prime. And negative 5, 6 will be my Z prime. And if I connect those points, you can see that what it looks like is I have a reflection across the y-axis. So again, you need to be specific. Saying reflection isn't enough. I kind of made that mistake earlier in the video. I didn't say rotate about origin, but you need to be specific for reflections and rotations, reflecting across the y-axis. And why the reason, remember this is the y, this is the x. The reason why it's important is, well, what if you reflect across the x-axis? It would look something, you know, that would be down here. I mean, obviously that's not perfect, but you get my point. That you need to be sort of like telling what you reflect across, because you can reflect across different things and get different shapes. Whoever watches this video, I hope you appreciate the fact that I paused it in between sheets, because this video is taking way longer to make than I think it does to watch. Anyways, facts about isosceles triangles. How can transformations such as reflections help us learn more about familiar polygons? Consider reflecting a line segment across a line passing through one of its endpoints. So copy the diagram A prime B. Well, A prime would be somewhere over here. B wouldn't move. So we would get something that looked like that. And we know that these would have the same length. Alright, it says when points A and A prime are connected, what do we get? Well, it looks like we get an isosceles triangle because they have the same side length there. So use what you know about reflection as making as many statements as you can in the triangle formed in part A. Well, it's isosceles. These angles have to be the same. I know that this is the midpoint of these side lengths. I know that that has to be a 90-degree angle. These angles have to be the same, right? So I don't know if I got that right, but what I'm trying to say is this angle right here to the middle has to be the same as this angle here. So there's a lot of different relationships going on there. Are there any angles that must be equal? We already said all that. Is there anything special about this polygon? It's isosceles. Again, that gets cut in half. That's a 90-degree angle, etc.